Hi everybody, today we're going to learn about solving systems by elimination, also known as linear combination, so you could hear those words used interchangeably. It is our third and final method that we're going to be learning for solving systems of equations. So let's go ahead and get started, if I can find the little thingy. There it is. Let's go ahead and get started. So elimination is just combining the equations. Basically, we're adding them together. And our goal is to eliminate one of the variables, so hopefully we're adding opposite coefficients, where the variable will go away, and then we solve for the remaining one. Okay? So how to eliminate? One, we arrange the equations in the system so the like terms line up with each other. So our x's are on top of each other, our y's are on top of each other, and our constants are on top of each other. Now the order that you do this doesn't matter. So you could have x, then y, then constant, or you could do y, then x, then constant. It really doesn't matter as long as they're lined up. Okay, 2, this step might need to happen, but it's good that we practice it. We're going to multiply either one or both of the equations so that we have one of the variables, either our x's or our y's, have opposite coefficients. That way when we add them together, that variable that has the opposite coefficients will disappear. So we might need to multiply it by a negative, we might need to multiply it by 2, or by negative 2 or something, to get it so it actually has like opposite coefficients, such as like 6 and negative 6 for the y's or something like that. Okay, and we'll practice it. 3, we combine or add the equations and solve for the remaining variable. 4, we're going to go ahead, once we have the variable, we're going to substitute back into the original equation to find the other variable, just like with substitution. And 5, we're going to check our solution to make sure each equation it works for each equation. Okay, if I'm going too fast, I'm sorry, it's almost 5 o'clock here at school, and I should be home already. So I'm going to try and go through it a little fast. If I'm going too fast, pause the video, write stuff down, go back, all that fun stuff, okay? Alright, so let's try some. So here's an example. We solve a system of equations by elimination. So first thing we need to do is line it up. You see how the x is on top of the y is on top of the x. Luckily our constants are on top of each other. We also, something to think about, we also want our equal signs on top of each other. So we're going to go ahead and fix it, so then we get this. Alright, all I did was just change around the bottom one. I subtracted 5x to be on the same side as the y, so that way they all line up. So the 4's are on top of each other, the y's are on top of each other, equal signs are on top of each other, and the constants are on top of each other. So, yeah. So, if we look, the y's actually have opposite coefficients. They have the opposite sign for 1 as their coefficient. So actually, that's going to be the variable that disappears. It's going to be eliminated when we add it. So let's go ahead and add it together. 4x and negative 5x make negative x. The y's are going to cancel each other out, and 6 minus 9 gives us negative 3. So now we just go ahead and solve for x, and where's our clicky thing? Divide everything by negative 1, so we get x equals 3. So now we know what x is, we're going to plug that back into one of these two equations and solve for the y. I'm going to plug it back into this one. So 5 times 3 gives us 15, 15 minus 9 gives us 6, so our solution is 3, 6. Again, sorry if I'm going fast, I want to go home. I want to go home. Yeah, that's it. Alright, let's try one a little different. So here the y's and the x's and the constants are basically lined up. However, we don't have any opposite coefficients. So there's multiple ways you could do this. You could get rid of the y's. You just need to multiply one equation by negative 1. Then the y's would have opposite coefficients. These x's already have opposite signs, but they don't have the same coefficient. So I could change that to get the same coefficient. And that's what I'm actually going to do. I'm going to multiply the entire equation by 3. Okay? So then it comes out to be 3y equals 3x minus 9, and y equals negative 3x plus 4. They're lined up, and my x's have opposite coefficients. So when I go ahead and add them together, 3y and y become 4y, and the x's cancel out. Negative 9 plus 4 gives me 5. Where's my cookie? Oh, wait, there's my cookie. So now I'm going to solve for y. I divide everything by 4. I get y is 5/4. An ugly number, but a number nonetheless. So we're going to go ahead and plug that back in. Plug it in for the top one. That was easier numbers. So I go ahead and add 3 to both sides. I now get x equals 7/4. So my solution is 7/4 comma negative 5/4. Again, not the prettiest thing, but it works. And I can always check it. Alright. Now I want you to try this one on your own. When you come back, I will have the answer for you. If I can find it in my little clicky thing. I'll find it now. Oh, I found it. Okay? So go ahead and solve it. When you come back, I'll have the answer. Alright. So here is our answer. No solution. When you did this, you'd have to multiply this top one by a, what am I trying to say? By a negative 2. What ends up happening is both variables get eliminated, so you end up getting 0 equals 20, which is not a true statement, so it's no solution. And now I gave you the trick one. Sorry. You can also get infinite solutions for this as well. Okay? Let's try another example. So this one, we got 5x plus 3y equals 5, and negative 6x minus 2y equals negative 22. We don't have any common, we don't have any opposite coefficients. There's not even things that we can multiply up to, so we can get 5, 3, negative 6, or negative 2. So we actually have to multiply both of these. And when you have to do that, you basically pick a variable, and then get them to have a common coefficient and opposite signs. Luckily, they already have the opposite signs. So I'm going to pick to get rid of the y. So I'm going to multiply this one. The only thing that 3 and 2 have in common is 6. So I'm going to multiply this one by 2 and this one by 3. So that gives me 10x plus 6y equals 10, and negative 18x minus 6y equals negative 66. So now I'm just going to go ahead and combine them. So I get negative 8x, the y's cancel out, and this gives me negative 56. Solve for the x by dividing everything by 8 and negative 8, and you get you get x equals 7. So we're going to take that and plug it back in, and I plugged it into the top one, I think. Yeah. So 5 times 7 plus 3y equals 5. I go ahead and get 35, then subtract that from both sides. So I get 3y equals negative 30. Divide that by 3, you get y equals 10. So your solution is 7 comma negative 10. Okay? So here's another try on your own. So again, it's one where you're going to have to work it out and get it so they have opposite things. Does that make sense? Okay, go ahead and track it. When you come back, I'll show you actually all the work for it. Okay, so since we don't have opposite things, you could try to eliminate the y, you could try to eliminate the x. Actually, I tried to eliminate the x, so I multiplied this entire thing by negative 3, and this entire thing by 2 again, so I can have them have common 6's, which means I get negative 6x plus 9y equals negative 3, and 6x minus 10y equals 14. I get rid of those x's by doing that, so I combine them. I get negative y equals 11, as these cancel out, which means y actually equals negative 11. I'm going to plug that back in, and I plug it into the top one. So I get 2x minus 3y times negative 11 equals 1. And multiply that together, you get 33. Subtract 33 from both sides, you get 2x equals negative 32. Divide by 2, you get negative 16. Your solution is negative 16 comma negative 11. Yay! And that's it. So I thoroughly expect I can't talk, I'm sorry. I thoroughly expect questions on this. So if you have any, please write them down on the side. I'd be happy to go over problems next class. Don't forget you have a quiz on graphing systems next class, so study for that as well. I will see you next class. And I'm not going to say bye because I can say bye. Goodbye!